a brief 2D cartoon explanation of how a wormhole works. Here's one simple way to visualize a wormhole. Imagine you have two pieces of paper and you punch a hole directly through the center of both. If you were an ant crawling around on either sheet of paper, looking in any direction, you would see a tunnel cutting across the paper, connecting all points on the left to all points on the right. According to this theory, gravity isn't a force, but rather a curvature in space-time caused by the presence of mass and energy. Imagine a bowling ball placed on a trampoline. It causes the trampoline to sag or curve downward. In 1916, just 4 years after Einstein published his theory of general relativity, physicist Carl Schwarzschild found a solution to Einstein's equations that described a region of space-time so warped that not even light could escape its grasp. This region became known as the event horizon of a black hole. Anything that crosses this boundary, be it matter or light, is pulled inwards and cannot escape to the outside. Such matter has never been observed, and its existence remains purely hypothetical. Even if it did exist, using it to create a wormhole would be extremely dangerous due to the intense gravitational forces involved. The Star Trek franchise, the crew of the Enterprise frequently travels back in time to different eras in human history. This plot device highlights the life-saving potential of such technology and makes us wonder whether it might be possible in the near future. These adventures often involve complex paradoxes and ethical dilemmas, raising questions about the nature of time and the consequences of altering the past. Similarly, massive objects like stars and black holes warp the fabric of space-time around them. One team of physicists has proposed a new method for detecting these elusive structures by looking for ripples in space-time called gravitational waves. Whether or not they ultimately prove to be a viable means of interstellar travel, the quest to understand these mysterious tunnels through space-time will undoubtedly lead to new discoveries and insights about the nature of the universe. When two black holes merge to form a wormhole, they release a burst of gravitational energy. As our understanding of physics and technology advances, we may find that these once fantastical ideas become reality, with their potential to revolutionize interstellar travel and communication. Wormholes are a tantalizing glimpse into the possibilities that lie ahead in our quest to explore the cosmos. One promising avenue is the development of advanced propulsion systems. But before you go, don't forget to leave us a thumbs up for more videos like this. And hey, why not subscribe while you're at it? We keep you up to date on all the latest scientific discoveries and space exploration news. Thanks for joining us today, and we'll see you next time. For example, some scientists are exploring the potential of warp drives to move spacecraft faster than the speed of light. Others are working on methods of generating antimatter to create powerful new engines. These futuristic technologies may sound like science fiction, but they are rooted in the laws of physics and could potentially make interstellar travel a reality in the future. By analyzing these waves, scientists may be able to identify the location of a wormhole and determine its size and stability. Is there life out there beyond our own planet? Let us know your thoughts in the comments below. When two black holes merge, their combined event horizons can remain connected even after the merger is complete, forming a tunnel-like structure through space-time known as a wormhole. As long as we continue to push the boundaries of what's possible, who knows what wonders we may discover. Even if wormholes prove to be too dangerous or unstable for interstellar travel, they could still have other applications. For example, some scientists speculate that wormholes could be used to send messages across vast distances instantly, or even to access hidden dimensions of the universe. According to Einstein's equations, wormholes should exist, but we have no direct evidence of their existence. Some researchers believe that wormholes may be too unstable to support interstellar travel, collapsing before a spacecraft could pass through them. Others argue that the immense gravitational forces within wormholes would be deadly to any ship or crew attempting to traverse them, Scientists believe that a wormhole could be created by distorting space-time in such a way that the two mouths of the wormhole are brought together, effectively creating a tunnel through the fabric of space-time. However, doing so would require an enormous amount of energy and mass. This theoretical wormhole connects to distinct regions of space-time, allowing for the possibility of travel between them. However, the interiors of these wormholes are shrouded in mystery, as nothing can escape from inside a black hole. We don't know exactly what happens inside a wormhole. Now, imagine those two sheets of paper are different locations in space-time, and the punched hole through them is a wormhole. Enter the wormhole at any point, and you'll exit it at a location light years away. You've taken a shortcut through the fabric of space-time itself. In science fiction stories, wormholes are often depicted as shortcuts through the universe, allowing spacecraft to travel vast distances in mere seconds. For example, in the movie Interstellar, the crew uses a wormhole near Saturn to travel to a distant star system. In theory, wormholes can be any size, large or small, open up anywhere and lead to any location throughout the history of the entire universe. They are essentially portals through space-time, allowing for instantaneous travel across vast cosmic distances. Unfortunately, despite their seeming simplicity, scientists have yet to prove that wormholes even exist. And those that have been theorized to exist pose significant problems for interstellar travel. Still, the very fact that we continue to search for these mysterious phenomena speaks to their importance in our quest to understand the true nature of the cosmos. What are wormholes? To answer this question, we need to look at Albert Einstein's theory of general relativity. Now, picture a piece of paper floating in this warped space-time, representing a ray of light traveling through the cosmos. As the light approaches the massive object, its path is deflected, bending around the bowling ball before continuing on its journey. This bending of light around massive objects is what we call gravity. So, according to Einstein's theory, gravity isn't a force, but rather a consequence of objects moving along the curves of space-time caused by mass and energy. But here's where things get interesting. As scientists continued to study black holes, they uncovered an even more bizarre phenomenon. But we do know that it takes a lot of energy to create one. In fact, current theory suggests that the only way to create a stable wormhole would be to use exotic matter with negative mass. Despite these challenges, the idea of wormholes has captured the imagination of scientists and science fiction fans alike. Wormholes have also been used in science fiction to explore more mind-bending concepts, such as time travel. In Andy Weir's novel, The Martian, astronaut Mark Watney is stranded on Mars and uses a wormhole to return home. However, despite their popularity in science fiction, the idea of wormholes has yet to be proven by scientists. Still, the search for wormholes continues. It's unclear when or even if we'll find any wormholes. But the search is already yielding valuable data about the nature of gravity and the behavior of black holes. While wormholes remain largely theoretical, they continue to capture the public's imagination and push the boundaries of scientific thinking. For now, wormholes are relegated to the realm of science fiction, but who knows what the future may hold. What do you think? If wormholes turn out to be impossible, then what other ways might humans achieve interstellar travel? Whether it's through wormholes, warp drives, or other means, the desire to explore the universe is a fundamental part of the human spirit. Well, folks, that's a wrap on today's episode.